Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about active methylene compounds, specifically reactions supporting enol form. Means what? In last video, I have discussed about evidence of structure of ethyl acetate. So there are two evidence. First evidence, I have already uploaded one video about keto. And in this video, we will learn about enol form of the ethyl acetate. And we will look at some reactions which favor the structure of ethyl acetate in enol form. So let us start learning of reaction supporting enol form or evidence in favor of Guthar formula. First reactions. You can see here, this is the enol form of ethyl acetate. Why it is enol? Because you can see first it was keto and now it is in dynamic form, enol form. So we are going to learn about evidence for ethyl acetate acid with the help of reactions, and this reaction will indicate enol form of ethyl acetate also exists. So you can see if this form exists, then it reacts with the sodium, is formed sodium salt of ethyl acetate. It's this reaction indicating ethyl acetate have enol structure. Now, second, it produces reddish violet color with ferrichloride solution. This point to be reference of carbon double bond carbon OH. If this is there, then only possible it reacts ferrichloride and reddish violet color with the ferrichloride. Third evidence for enol form of ethyl acetate is this reactions. It discharges the color of ethanolic Br2 solutions, giving addition reaction, which shows presence of olefinic double bond. You can see here this Br2 added and this double bond break into a single bond and dipropyl substitute product obtained. This is indicating presence of this double bond, means enol form of ethyl acetate. Now the next, on treatment with phosphorus pentachloride PCl5, it forms ethyl ester of beta chlorocrotonic acid. PCl5 is used for the conversion of hydroxyl group into chloro functionality. You know, this is very well-known reactions. Hence, it has been again proved from this reaction that hydroxyl group is present in ethyl acetate. So this is indicating double bond. This reaction showing if OH is group there, PCl5 definitely react with this OH group and convert to the Cl and forming beta chlorocrotonic acid. The formation of beta chlorocrotonic acid is the evidence for the enol form of the ethyl acetate. So my friends, thus structure of ethyl acetate remained a point of discussions until 1910. The controversy was resolved by Knorr in 1911 when he succeeded in isolating both tautomers in pure form and showed that two forms are readily interconvertible. Now problem solved, because now the Knorr explained keto form. You can see here. This keto form, ethyl acetate 92% and keto enol tautomer you see 8%. So some reactions before that showing the enol form, some reactions giving information about the keto form. Then he make the conclusion, he isolated both the products and shows that these two products actually are in dynamic form and interconverted, you see, 92%, 8%. So not in 1911, who succeeded in isolating both forms, he cooled a solution of ethyl acetate in light petrol to minus 78 degrees Celsius and obtained crystal which melted at minus 39 degrees Celsius. And this substance gave no coloration with minus 78 degrees Celsius and did not combine with the bromine and was therefore the pure ketone form corresponding to Frank-Land 2 formula. Nor then suspended the sodium derivative of ethyl acetate in light petrol to minus 78 degrees Celsius and treated this suspension with just enough hydrochloric acid to decompose the sodium salt. He now obtained a product which did not recrystallize but set to glassy solid when cooled, and this substance gave an intense coloration with minus 78 degrees Celsius and was therefore the pure hydroxy group of form corresponding to Gunther formula. So the stability of enol form is ascribed to the formation of intramolecular hydrogen bonding. This is the reasons. Acids and bases catalyze the interconversion of tautomeric forms, and mechanism for acid and base catalyze transformation by the retain, as you can see here. The acid catalyzed tautomers starting from acids and base catalyzed tautomers. Keto forms, base, anion, this is anion, this is enol form. Now, proof for structure of ethyl acetate by Claisen condensation. Base catalyzed condensation of an ester containing an alpha hydrogen atom with molecules of the same ester or different one to give beta keto ester is known as Claisen. Beta keto ester is called Claisen condensation. So, two molecules, you can see alpha hydrogen of ethyl acetate react with sodium ethoxide and forming ethyl acetate. This is it. Now you know the mechanisms. Generally accepted mechanism for the Claisen condensations like this. This ethoxide taking this proton forming enolate anion. Enol and another molecules forming this structure. This is under dynamic conditions and this compound showing the keto-enol tautomerism. So now problem is solved because previously the structure is supported by keto form, then enol form, and then finally keto form and enol form exist in dynamic form. So Claisen synthesize this compound. So step 1, removal of an alpha hydrogen by base give resonance stabilized anion. This is step 2, formation of new bond between enolate and nucleophile and carbonyl carbon of another molecules of ethyl acetate. And step 3, breaking of bond to give a stable molecule of ethyl acetoacetate. So my friends, I hope this video will be very helpful to you. If you like this video, then subscribe my channel and thanks for watching.